Hey everyone, today we're going to solve the problem container with most water problem. So you are given an integer array height of length n. There are n vertical lines drawn such that two endpoints of ith lines are I0 and I height of ith index. So find two lines that together with the x-axis form a container such that the container contains the most amount of water, and return the maximum amount of water a container can store. So you are given this input array, and this input array can be visualized as this graph. So let's understand the problem more. So you are given an input array, and the values are going to be the height of these bars. This x-axis is the index of the array, and the y-axis is the value or the height of these bars. With two of these bars, you can create a container. So let's say you have picked these two bars and you can form a container with them. So what is going to be the height of that container? It's going to be the smallest value between the two height, which is 1. Now why smallest value? Because if you put too much water that the container can contain, then the water will start to overflow. So you have a container like this, and if you keep pouring water, then the container will start to overflow. So that's why you need to choose the smallest value. So the height is going to be 1. And what is going to be the width? The width is going to be the difference between two indexes. So we have index 1 and index 0. 1 minus 0 is 1. And you can find the area by multiplying the height and the width. And 1 multiplied 1 is 1. So that's the amount of water this container can store. And you need to find such a container that will contain the most amount of water. So how do we solve this problem? Now you might be thinking that you need to get the two maximum height and then calculate the area and return. Well, that's not going to happen. So let me just put the index values so that you can see it better. So if you take the height, which is 8, both of the values are 8, and the difference, the width is going to be 6 minus 1, which is 5. So 8 multiplied 5 is going to be 40, but that is not the correct answer. The maximum container can be formed with 1 and 8 index. So there the height is going to be 7, and the width is also going to be 7. 8 minus 1 is 7, which is going to be 49. And that is our max value. So how do we actually solve this problem? Well, the brute force approach is going to be using a nested loop. You generate all the containers that can be formed with this array. You calculate the area and get the maximum area by tracking a variable, and then you return it. The time complexity will be O of n square, which is not good. So what can be our optimal solution? Well, we can use a two-pointer approach. So one pointer is going to be at the left, and another one is going to be at the very right. And now you can form a container with this two height. But before that, you need to create a variable to keep track of the maximum value. I'll call it max. So initially it will be 0. So in this case, the height will be 1. The width is going to be 8 minus 0, which is 8. So 8 multiply 8 is just 8. So our max variable would be 8. And then you need to add a condition. Which value is smaller, the left one or the right one? Whichever is smaller, we're going to shift that pointer. So for example, if the left value is smaller, then we're going to shift the left pointer to the right. If our right pointer is smaller, then we're going to shift our right pointer to the left, because we want to have the maximum value, and keeping a smaller number will give us a smaller result. In this case, our left pointer is smaller, so we're going to shift our left pointer to the right. And now we can form another container. We have already calculated this, and the result was 49. So we can update our max variable. And this time our right pointer is smaller, so we're going to shift it to the left. And if we calculate, the height would be 3, because it is smaller. And the width is going to be 7 minus 1, which is 6. 18. and 18 is smaller than our max variable, so we're not going to update it. And you're going to keep running this logic until the left pointer is equals to or bigger than the right pointer. And after calculating for all the containers, we're going to have our max value, and then you just have to return it. The space complexity is constant and the time complexity will be O of n. So let's write the solution. So first create the pointers. And let's create a result variable. Let's run a loop until the left is bigger or equals to the right. So left will be smaller than the right. We can get our left and right values. And we can calculate the width, right value, the right index value, minus the left index value. And let's get the height. So it's going to be the minimum between the left height and the right height. And let's get the area, which is going to be height, multiply with. And now we can update our result variable. If the new area is bigger, then we're going to update it. Otherwise, we're going to keep the result variable as it is. So result math.max result area. And now we need to shift our pointers. Whichever is smaller, we're going to shift that pointer. So if left height is smaller than right height, then we're going to shift our left pointer. So left plus plus. Else right minus minus. At the end, we're going to have our result. So we can finally return it. So let's run the code. We have an error. Input is not defined. Oh, the variable name is height, not input. So I will rename the variable to input. And it has accepted our solution. So that's it for today's video. If the video has been helpful for you, don't forget to like, share, and subscribe to my channel. You can also check out my other channel, Cules Coding, for full stack web development tutorials. You can also reach out to me on LinkedIn or Twitter as Daranjan, and I'll see you in the next video. Goodbye.